Okay, apologies, we said we're going to start at 11. We do have a bit more time there, and I thought it was important to socialize as well, because it's all about networking as well, so we're very agile, adapting things. So yeah, I've already actually introduced you while you were not here earlier. I introduced you yesterday as well. So this is Obins Cloudhary, that's right? Yeah. And what is your specific role at Barclays?
So I'm a Vice President for Artificial Intelligence.
He's the right guy to talk to. So Paul, back to you. Looking forward to your presentation.
Okay. Thank you guys. So before we go ahead, can you know how many of you?
Make sure this thing is on. Hello, hello. Yeah, just closer to you.
Okay. So how many of you are here from business? A lot. Cool. So we have been talking about artificial intelligence and the execution part of it, a lot of the academics of it, but the challenge, the real challenge is when you bring AI to big enterprises, and that's where I would like to talk to you about the journey for AI that we started in our bank. And for last 2 years, it was not that easy. It was, I would say, rather it was very painful for us. So where does it start? So we had a problem statement that we had to increase the product activation for our customers. And as a bank, we were selling a lot of products to our customers, but it was not getting activated. So we were reaching out to our customers in multiple ways: campaigns, SMS, and emails, maybe. So the challenge was they were not coming back to us, they were not interacting with us, they were no matter, even if they're buying the product, they were not using it in a way that we wanted to see. So we had to go through research that, like, what we can do. We went to branches, we went to universities, campuses, and public areas to see what can happen, like what we can do for such customers. So this was still the early days of the chatbots and deep learning in African market. So what we came across was, then it was a chatbot, but it was not yet released on Facebook. It was still for the Telegram and Slack, and we wanted to get it working for us. We found a startup who were working on this, and they gave us a product. Like, we spent a lot of time with them. They gave us a product, and when we actually went for the testing, we realized that it was, is it visible from that side? Okay. So what we saw, it was nothing more than an USSD. So type 1 to do the payment, type 2 to do this, and so we were really, it felt quite embarrassing for us to go to the market with such product. So we thought, no, this is not going to work for us. So we don't want to embarrass ourselves. So we started researching into it and to see what we can do internally. So we found some platforms in the public forum which were quite good in machine learning, and we were quite happy. We were quite happy with what we developed on that platform. And now the time was to go to real customers this time. We went to branches again to talk to different segments. We went to internal employees to talk to them to see what are the experiences there. So now what happened was, again, very interesting, because we thought we had developed a very interesting product for them, and they would get very excited about it. They would use it, and we will be like, okay, we will be popular at least in the bank and everywhere. But again, it didn't happen. because they didn't know how to use the product. So when we were building some of the most advanced chatbots for them, they didn't know how to ask the question. They didn't know what to ask there. So, okay, so you have a product, but it's not working for you. So the customer didn't know what to ask. Even if you're telling them, please ask something, anything you would like to ask for the bank. If you're in the branch, we ask them okay, what are your queries? What do you want to ask? Why you have come to branch? Can we help you through the chatbot? And they would ask random questions. They were very confused. What is this? What's happening? And so we took a step back. Okay, this is not working, and this is no matter what you are trying to do, you have to think through customer angle, and that's why maybe that's the point I have put here. That no matter what you're trying to develop, no matter what you're trying to achieve through your product or your innovation research, you have to think from the customer angle. You have to think, who is your real customer? How do they will react to you? How do they think about your products, and how do you want to engage with them? So yes, it's good to have a problem statement, because that's where you start with innovation. You start with real work, which you can take to the ground. But it also becomes quite important that you understand how you develop your product, how you take it to the market, so our customer appreciates it and they start using it, because that's your end goal. To take your customer from point A to point B, where they can start utilizing your product, they can engage with you, no matter what product it is. It is chatbot, it's just one of the examples, but there can be a couple of other examples where you can use, say, automated responses for your email. Then you can use automated onboarding processes, where you can use the deep learning techniques like computer vision to do some of those. But the challenges would be still the same. You have to come up with an interface that gives seamless customer experience to your users. So, and that talks to this, like you are developing this very out of the world product, but it starts really getting confusing. So, okay, this is not readable, but so usually what happens, you have done wonderful testing. You have gone through multiple layers of technical unit testing, and then still, when you go to the real customer, you find that the product is not working. No matter how much you have trained it, no matter how much data you have collected, the most advanced model that you have used, but in reality, things do not work. And there could be multiple reasons for that. Maybe, and I will take you through some of them now, like how we can get away with such challenges. So this is just one of the examples that I pulled from the internet, where things really went wrong, where user was trying to ask something and chatbot didn't understand, but still it came back nicely and helped the customer try to answer in a way that made customer at least happy at the end. So yes, that should be your real goal. So even you might lose your customer at some point, but the end goal, the customer should always reach to their end goal. They should be happy. They should be engaged with you in a way that they come back to you for the next product offerings. And that goes to a very clear representation of like who is your real customer, who is your true customer. Because if you're trying to target everyone, that will be a problem. You're trying to go to branch, you're trying to go to youngsters, you're trying to do it with all different segments. So someone who are very geeky, someone who doesn't know the technology. So how are you going to deal with that? So you have to box your product, at least for your MVP, which is minimum viable product. So when you're launching your first version of it, you have to be very attentive, careful who you're going to. So that in the first, at least you do not get that setback in the first stage. You are able to at least prove the value of your entire efforts that you have put in innovation, research, and whatever techniques you have used. So no matter what techniques you have used, let it be the basic, let it be the very simple one, like Thomas said, that whether it's complex or simple, in the first place you have to prove the value out of this. So if you are able to prove the value through very simple model, and if customers are engaged, customers are happy with that, okay, then you can definitely scale up from there. So that's a learning that that comes after after a very long time. You don't realize that. You are always in a mindset that, oh, your product is great, you should have that amazing experience for your customers, and there's nothing wrong with your product, but it's the customers who do not understand that. So you have to come out of that mindset. And it's also quite good to have that feedback mechanism, because otherwise you don't realize that what kind of product you're building, what kind of experiences that you're giving to the customer. So it's always good to have a feedback mechanism for you, and this goes quite well with the Uber app. So when Uber came back, when they came up with this technology, and so they integrated several new models, and they found that it was just not working for them. So, and customers were really getting pissed off. So they put this feedback loop where you can start rating the either the driver or the app, that how it's behaving. And I guess you need to have that feedback mechanism in whatever product you are developing. So yes, if it's AI product, you need to create that loop where your data collected from your product goes back into your model, and then it retrains. It trains the data, it iterates it in a way where you have a better experience at least the next time. So, okay, in the first time, if customer finds it really difficult to understand, customer can understand. But if it's happening repetitively, then customer will get pissed off. They wouldn't want to come back. So, and they can also appreciate it when you have fixed it. So you are working on something, you had this problem, but you have fixed it going forward, then yeah, that will at least excite them that, okay, this is no more a problem on that platform. So that goes to data. So no matter what product you are developing, you need to understand your data. You need to have a proper understanding of what your data looks like, where it is lying in the organization, how you have to get it, how you have to work on it. Before that, like, you shouldn't be making any decision for your customer, for your management, for your executive, anyone. Because what happens, you think you have a great model, you have a great understanding of the product that you want to build, and you go ahead with that, and you claim that you can get it done in 15 days, in 30 days, and you will roll it out to your customers. But in reality, that doesn't happen. You get the setbacks from the place where you could not have expected. So you need to have that check, that what do you have actually, and can you go further from there. So at the very initial stage, like before even you have got any model in place, you need to look into the data, and data can look terrible. Let it be text, let it be image. You have to work on the pre-processing of it. So any organization can claim like they have tons of data, they have massive data sets that for voice, for video, for images, for text, and they can work on some of the amazing models because AI needs just the data. But it really comes down to to the quality of data that you have. If you do not have the right representation of the hypothesis that you want to prove, it will not. So if your data is not, it might not give you the kind of result that you're looking for. So if you're looking into the data, it's a very good perspective to see if you can clean that data, if it's possible to do that. So if you're working for the text, you can again use several methods, and because the data can be coming from different sources. It can be email data, it can be your complaints data, it can be either social media data, all the interaction points from the customers in, say, Twitter, which is just a junk, but if you want to get benefited from those data sets, then you have to work on pre-processing. And this goes with voice, this goes with image, same. So you need to work on it, you need to see how it's looking after the processing. Then, once you have done that, you need to understand how much of your data is correctly labeled, like you mentioned. Because when you are claiming that you have data, the major pain point is labels. You can say you have large amount of data, but it's a junk, because the technique that you're gonna implement for these methods, any of your deep learning, it's 90% chance that you will be using supervised learning. We are not yet there where we can start implementing unsupervised learning at least in production or in enterprise space, because you don't know what's going to come out of that, and you don't want to take the risk of that. So you will still want to play safe in that area, and that goes back to labeling. So if you don't have the right levels, you cannot work with it. So now, a lot of time would be invested just in creating these labels for you, and you have to consider that. So if you have now considered like 30 days to launch your product, now just take it to 90 days, because your 60 days will be consumed just to label the data, no matter how much resource you put into it. Because from the experience, we gave it to the business, we gave it to the interns, we gave it to the freshers to at least help us with some of the labeling. What came back to us was junk again. Because we gave them enough guidance, this is what you have to do. This is how you have to understand. This is a painful job. Labeling is a painful job, and whoever has done it, they understand it. It's very boring. They don't want to do it. After doing it for like an hour, you just want to do it. So no matter you're putting an expert there or a fresher, they will just not come back with the quality output that you want. And I was reading through some of the articles from Andrew Scarpati, who was working on international image competition. And the competition was going to happen in next 2 days, and they didn't have the data with labels. And that was the international image competition, where they throw the almost the 10 million data source to the competitors, and whoever comes back with the most, with a higher accuracy, they. But you can only go to the accuracy if you have the right labels. And he literally built a platform where they can manually do all the labels. And he had to do that in like last 2 days, and he had to involve all the teammates or other scholars who were working with him continuously for 2 days to get the data ready for the competition. Because nothing matters if you do not have that one thing. It becomes easier for the image. Text is really difficult. It becomes easier for the image because you can still utilize semi-supervised methods. You can utilize some of the scrapping methods. Then you can utilize techniques where you can combine your text generation along with the image images. So these are one of a few examples again from that Karpati's blog, where he has used different types of labeling, but he also mentioned that when you're labeling, you need to have that detail of the label, because when you're working on the model needs to understand your data, and it will understand the data when you start giving more and more details to the kind of classification you want to do, the kind of learning you want to do on your training data set. So telling it this as just cat wouldn't help much. So you have to go further and give a lot of details. And same as the example with the text labeling. So if you just say, okay, this is a FICA problem, you just give the FICA, okay. But next time you have another problem where you have to find something else, then you will have to relabel everything. So in the first step, you have to be very aware that you get those labels right, detailed labels, if possible. So there are various ways to do it, to label the data. Either you can sit for long hours to do it manually, or you can use the crowdsourcing for that. It doesn't help much, but you can get good quality of data to a certain extent. And this is one of the platforms which can help you. So Mechanical Turk is just one of the tools from on AWS where you can decide the rules that how you have to create your data sets, how you have to label them, or whatever tasks you want to create. Plus, you can also create the validations or the rules that what is the quality of the labels that you are generating, what is the quality of the task that you are doing. So it's quite possible to use these techniques to do the labeling. Again, you can use generative models. It's both on image side and video side. So you can use the generative adversarial network for that. But the kind of result that you're going to get, it's difficult to predict. It can vary from very expected results to some of the results that you would not even want to look at, especially. So there could be different methods to do it. You can combine generative methods along with the other supervised approach. So that will be the semi-supervised approach. So what happens in semi-supervised approach? So say you want to label maybe 100,000 data for the start, and you have only 1,000 or 2,000 labels. Then you start with whatever you have as the labels. Then you start creating, and then you put all those data which are not labeled, and you use generative models to kind of use along with the supervised models to get something which is halfway. So you can be better at the data quality. So that's that you can use as well. So the other one is a lot of augmentation that can be done on the data. So, but it's also restricted to some of the data sets that you want to work with. If it's image, it becomes easier for you to use very basic techniques like rotation, changing the contrast, image quality, zooming in, and providing different kinds of effects that could possibly have in the real life scenario. The best part of this, in reality, when you are collecting images, when you are collecting data, or when you are testing or running your model in the real life scenario, you will get these kinds of data. Because you have trained your model on a very high quality picture, but in reality, it can completely distorted. It can be completely, no meaningful information could be available there. So you have to train your model on such data sets so that you are prepared for really bad quality images. Yeah, and that goes back to a very simple thing. If you put the garbage in the model, that's what you're going to get out. So you cannot get the high quality output from your model if you're not putting a high quality data in your model. And you have to put all the efforts and time in bringing that quality of data. So yeah, we say the modeling is the fun part, but okay, let's get into the bit of details of it. It's not that fun all the time. So when you have to work on the model, you have to think about the different complexities, whether you want to use a very simple model to prove the concept that you have, or you want to use a very complex model. So, like I said before, start with something which is very simple, so you can get it going, and then very soon you can be more prepared to scale up your application for the different techniques that will give you better confidence in it. So, for the text data, it's advisable to use a lot of embeddings that you can create for yourself, especially for your organization. If you are able to create embedding for your organization, then it gives you the dictionary for everything you can possibly want to create over the time. So this is just one of the examples from the TensorFlow projector, which is a very generic example, but let me show you in a bank environment, where we get different types of data sets. And so this is IB, this is just one of the terms, and no one would understand that. But what happens when you are putting these keywords, if it can go, you can see it picks up all the spelling mistakes. It can pick all the variations in it. So if you see, it's putting cat. If we're searching for cats, it will look for HEM, it will look for different types of cash forms, money, and it will include all those spelling mistakes. So this is what you really need to create before going for at least for the text models, so that you understand your data very well, and the model can understand semantic or the understanding of what you have inside your data. You can, if you have created your embedding quite well, then you will see very good results. So, like, no one will imagine that this IB can go back to Firefox, because someone might have complained that my Firefox is not working, or my internet banking is not working. So for us, we cannot relate it, but model can relate it that someone has somewhere mentioned that Firefox is related to internet banking, which is creating a problem for them. So that's where you understand that, okay, if it's internet banking, then there could be a few pieces around the browser or the Firefox. And that goes same with some of the other keywords that you create for yourself. With the one embedding, you also get the benefit of creating different variations of it. Like this is one of the other examples where you can it's just those popular examples where you put king plus man or king minus woman equals to queen, which is a very popular example from the word embedding, but what we have used it for some real problems. So where we, like if there is a lending product and we are combining it with credit product, and if we don't want to use certain other words which might be related to that. So then we can clearly see these are those keywords where we need to focus on. So if we get that right, it works really well in the model. So when you create deep learning models, you put your embedding layer as the first layer, and from there you can either use your convolutional or LSTM or bidirectional LSTM to further do the classifications or whatever training you want to do. So, and that goes back to the question that do you really need the complex models all the time? You might or might not, but if you're considering for the complex model, can you simplify them in a way that it is more stable? It gives kind of similar results. Even if you're using the deep learning model, something like if you're using the convolutional, you can rely on the results or the simplicity of it, because you are using some of the very basic functions of the neural network, like the windowing function or for the classification, which gives you more reliable result. And rather than using a model like Inception, where you have 18 or 20 layers of convolution with max pools and a lot of like fully connected networks. So you want to rely on the networks which can give you similar results. So when we are using these models, we tend to say that these are the black box and we don't understand what's happening inside it. But when we are putting something in production, in customer-facing area, then we need to deconstruct these models. We need to understand how these models work. Because if you do not understand how this model works, then it will be really difficult to debug it when you have a problem statement in the real world scenario. So you have to start writing these models in the simplest form. You have to write these models using the core libraries. So say if you're writing your model in TensorFlow, stick to that rather than using Keras or any other wrapper like TensorFlow Learn, because you can definitely use those wrappers, but you cannot debug them, and that's the biggest challenge in the enterprise environment. So this is just one of the examples where if you're working with the text to data, how you can deconstruct it. So this was the example taken from Andrew Scarpati's website on blog, where he gave the model 200 books to learn on it, and then he started creating the generative text out of it. And you can, he was using different variations of LSTM for that. So you can see after certain iterations, it starts generating some words, but it hardly makes any sense. But if you go further, you can see it starts learning that at least those spellings of some of the smaller words, it also understands some structure in the sentence, that there is a comma, there is and these variations. And if you run it for a specific number of iterations, depending on the use case that you want to create, you'll start getting the good results. So you need to visualize those results. You need to understand that what's happening, and it can be any model, possibly text, image, classifications that you are trying to do. So this is for convolutional neural network. So it doesn't do a magic. It tries to understand the different layers of it. It tries to understand in the first layer just the different patterns, then edges, different shapes, then more complex forms, and then later on different parts of the faces. So this is just one example, but when you are writing your own program in convolution, you need to understand that in the first layer, whatever functions you are writing, what kind of filters you are applying, what are the different sides of the filters, why you are applying different sides of the filter to your model, so that it doesn't create a problem. How you're doing the padding on top of that, how you're doing the max pooling, why you're doing the different types of pooling methods, why you're applying different layers of it. So you could possibly, for a very simple form, you can apply 3 convolutional layers, and you can go deeper than that if you have to implement that. But you need to understand that by deconstructing it, so you can replicate those results. So this is example of deconvolutional neural network, which can also be used for adversarial network. So in the deconvolutional neural network, it tries to bring your noise down between your actual real data and artificial data. So it will generate artificial data, but it will continuously iterate it where it can reduce that noise. And if you're using such models for your production, then you have to be very careful that what is coming out of it. You should understand it, you should validate your data before feeding it into the model. Because what happened to us, we were very excited about using generative models, that okay, we can now generate the data, we can use it to train the models on top of that. And now, instead of having just 5,000 data records in the data set, we have 100,000 data. But what was the quality of data and what was the output of it, we really didn't bother to think about it. And when you feed these data in your model stops performing to, or stops giving the accuracy, the kind of accuracy that you want. And so then it also goes to that accurate point where your model can be highly accurate, at least theoretically. You can have very high accuracy on the model. Say you have good 90%, you have tested your model with 90% accuracy, but in real world scenario, it's just not working. You have done your proper validations, validations on your training set, your test set, everything is fine, but still it's not working. And so how do you relate your model accuracy with the customer satisfaction? Because the end result is that experience that matters. Because the whole objective of doing so much work is to convince your customers that they are getting a better product, they are getting a better output. If it doesn't solve their problem or add to their frustration, then we shouldn't be rather doing these things. So always think about are you able to satisfy your customers, give them the kind of output they want, or you're just focusing on your model accuracy, whether it's now 90%, 95%, and you spend more and more time on keeping your model highly accurate. So okay, so if you have to work on if you're really working on the accuracy of the model, you have to think what you can do from some of the transfer learning techniques. Do you want to exploit the techniques right from the scratch? Do you want to build a model on your own, or do you want to use something that the community has built already? They have tested it, they have proven a value out of that. So so it's not about just using those models, using those weights into your model, but it's also about how creatively you can use those weights that they have set. So say for example, you're using inception model, which is considered to be one of the best image classification model. And because of the certain architecture details that they have put in the model, which is considered state of art by every scholar in this industry. So definitely you want to utilize what they have got there. And they have trained the model on millions of images, which will definitely give you age somewhere. But then, when you are training it on your data set, you have to make sure that when you are unplugging the top layers, the fully connected layers, or before the softmax function, or whatever output layer you are using, you need to test that properly. You need to put the right data. You need to do all the validations in your output layer, and so you can get a kind of output that you expect from the model. So it is very helpful. It saves a lot of your time from experimentation, from doing, and especially AI is a very new space. So everyone wants to try and do something exciting. They can spend as much time as they have. They would like to do something either in 15 days, or if you give them 90 days, they will still go with that, because they will have some model to explore, they will have some techniques to implement, and they will keep playing. So you have to put that deadline where you need to stop doing research and get into production phase, where you need to think about the enterprise execution. So we don't just keep experimenting, but rather land some value for the organization. So now, this is a very simple mistake that every data scientist does when they are working on the data. The challenge is they tend to overfit the model very easily. The reason for it, it's not technically wrong, but what they do, they will just start to, they have collected all the valuable data, they have worked on those data to have done enough pre-processing and all the augmentation and everything they could possibly do. Now, when they are tasting their data, they found that there are certain things that they can definitely fine-tune in their model. So they start using different tuning hyperparameters, and when they do it, they come back and they test the same data sets once again. And this is so common in the industry that they forget that you need to keep unseen data separate from your seen data. Otherwise, you are just overfitting your model. You are giving them all those features that model already knows. So in the next, so when model gets exposed to the again real life data, it performs really bad. So you have to think how you can get away with that. So that's some of the details that you need to consider. Also, when you're working with it, you need to understand what is the human level performance. So say if you're working with image data, and human performance or the human accuracy is quite high on image data. It can go up to 95, 96, 98%. And if you are training a model, if you are generating an output on your image model, and you're giving the output to 80% or 85%, it doesn't matter, because it wouldn't give you the kind of result that you want, or it wouldn't add a lot of value that you want to add to your product line for your customers. So you need to understand that what's the human level accuracy of the performance. Say for you go to the text classification and or the voice to text. Because of the noise and the quality of the data, you will find some of the best recordings that you have from your contact centers or the data from different sources. The human understanding or the accuracy is really low. It could go down to 70%. And in those areas, if you are generating some output with 85% accuracy, that matters. That matters to you. That adds a lot of value to the organization. So you have to understand where is that human level of accuracy, and are you surpassing that? Okay, so say if, now you have built your product, you have tested it, you're happy with the model, and now you're ready to launch it to the market. The challenges could be immense that you cannot even think of, or you have not came across. In the first place, most of these models that you're building, you have built it on your laptop, some high configuration laptops of data scientists, and they have got good accuracy. Now it's time to scale this up to bigger organization. Now, how do you get all those necessary infrastructure for the organization if you have to deploy that? Because if you go to enterprises, in the first place, they do not have the very basic component, which is GPUs to run these models. They will have really big servers. So but they wouldn't have the GPUs to train these models. Now, how would you deal with that? So either you train your model every time on some small GPU servers and share the weights between your serving model and your training model. That's quite possible. But you have to consider that prior to going in production, that this is what's the case. On the big servers, you can only utilize CPU to serve those models, so you have to train the model somewhere else on a small box and then share the weights between them. Then, because of the data challenges and that you cannot move the data in enterprises, and you really want to move quickly to show the value of your use cases, you have to consider different ways. Whether you can run it on a small box in the enterprise, whether you can use a cloud to prove the value, or you can just get hold of some virtual machines that you can run. But you have to be very attentive about that. Okay, this is the infrastructure, these are the limitations that I will come across, because even no matter how advanced platforms that you're using, like Docker or the VMs, it might or might not work in a way that you are expecting, especially with the libraries and the upgrades that you get on these libraries. They do not go along together. So some of the libraries will work quite well with your Java. It can not work with some of the other libraries that you need. Say TensorFlow, there's so much changes every time it upgrades that it breaks all the previous versions. And yes, so when version 1 launched for TensorFlow, it literally, all the models that we were running in 0.9 was not working anymore. And they just don't change the model, they change the whole path of those packages. And this is so painful that you have to rewrite literally everything. So yeah, those are the things that you have to consider if you're going to the production, that are you using the right tools or the packages along with the infrastructures. Like I said, if on top of that, if you're using a wrapper like Keras, good luck. I mean, you will be lost for what happened and how what's happening now, what you have to do next. It's just because the new Keras, the new version of the TensorFlow might not support the wrapper that you were using. So, or the Keras have they have not written all the new packages or on the new upgraded version. So you will have to wait for that. That's why you have to stick to the core libraries and write it, understand it, reconstruct it. Then, in most of the cases, when you are working with these use cases, you will be integrating your application with the internal system. So it's not that you have written a program or an application that runs all alone. You have to make use of the data that you have in the organization, and you have to integrate with them. The challenges would be you do not have a pipeline for that. You do not have the regular extracts running for you. You do not have any streamline that can feed into your model. So you have to consider beforehand that how you're going to integrate with your systems. Otherwise, your product is ready to launch, and maybe you have launched your MVP, you have proved your value, but the next stage is not working, and that's the integration. If you see the real life example of most of the startups, they fail because of this. They come up with very interesting use cases with the very interesting solutions, which would work for the MVP. They would go to the big organization to do the POC, they will solve the problem, they will showcase the value. Now it's time to integrate with the internal system, and they have not created API layers. They have not created the layers that can connect to the enterprise systems. Now, enterprise do not expect to give away their data or to let you connect to their, even forget the startup, even if you're working internally in the enterprise, they will not allow, one team will not allow other team to access the data because of the ownership and all those problems. So the only way that we have found is to give access to your model through different ways to them. So at least they can consume your service, whether it's through as a software as a service, application as a service, or API, in whatever form you want to give them. You will have to think about that. So you don't get delayed on your execution further, or you do not stop after your MVP. You have to keep going here if you have really nice use case. Then, say you have proved your value, you have gone to production, you have used some of the, and customer, say your client is happy, the enterprise is happy with the result that you have got. Now they ask you, okay, but how about bringing 2 more use cases on that? So you shouldn't be in a situation that you have to start from scratch. That, okay, what's going to happen now? How would I put different variations of the use cases? How would you work on that? So you have to consider how you will be using serving different types of serving. How would you train on the different data sets? Maybe you have the same model, but or the little bit of variations of it, but how you're going to manage the different versions of it, for the different use cases. Say, for example, if you're building a bot for your organization and you have successfully proved the value that, okay, now at least it works, it has all the interesting features that you were looking for, but they come back to you, they say, okay, I need it for now legal, I need it for HR, I need it for infrastructure, I need it for other internal services or other employee engagement. Now, at that point, you shouldn't be thinking like, what's next? You should be able to provide service to all those use cases. And this is the point where you really have, you are really growing fast, and you have to keep growing faster after that. And that's the place where you add most value. So if you can scale up very quickly, then you can really make good money, plus you can generate a lot of revenue for your organization. So, along with the multiple use cases, you can have challenges with the multiple versions of the model. Like we just talked about the different versions of the challenges with the different packaging of the versions. You can have different variation based on your use case, but you have to run all those models simultaneously. So how do you package those checkpoints? How do you package those model bin files in a way that you can access any of those versions at any time? So especially if you're serving the model or using the big platform, and you have to do A/B testing, you have to switch between 2 different versions of your model. So you have to see which model is working better for you, which version is working better for you. Then you cannot keep plugging and unplugging your different models. You have to create that as a framework, as a platform that does it quite seamlessly for you. Yeah, so those are some of the learnings that we had during the productionization of the AI use cases. So yeah, the problem is we keep assuming a lot of things about AI. AI can do this, that, but in reality, you have to work really. You have to put really a lot of efforts to get it right, get it working, make it scalable, make it something that can generate revenue for you, and not just is experimentation area. So you have to consider those things. So thank you. If you have
any questions? You can see there's another example of real-world experience. It's not always as simple and easy to implement these kind of solutions and stuff. And I would just very quickly, so you mentioned you started about 2 years ago, is that right? So it was with
yeah, for different products.
Yeah, for different products and stuff. And how long does it typically take to take the product through the whole cycle?
So depending on the use case and the organization that you're working for, and how much agreement you have with the senior management, because you cannot go ahead with anything literally without the acceptance from the senior management. So you have to consider that, and you have to consider those points. But if everything is in place, I would say you run your MVP in 90 days with your alpha beta testing. So if you are able to build your model in 30 days, very quickly find some value in your model, then go for proof of value, how you can prove the value in. So next 60 days maybe is spent with pilot customers. So what they're doing, what are their reaction to you or response to your model, what are the feedbacks that you're getting. Maybe next 30 days would be improvement on that. So once you have this feedback, or you can parallelly spend a lot of time improving those things on your model. And there would be other challenges on integration that you have to consider. So I would say 3 months for your MVP. Then for productionization, it can take anywhere from 3 months to 6 months, because productionization is that tedious process where you have to get basically acceptance for architecture. So because what you're building is just a model. There will be whole ecosystem around it where you are consuming the data, where you are serving, where you have developed your user interface, and those things take much longer than what your modeling will take. So you have to consider all of these. So from productionization perspective, you have to put some timelines for that. So you need to get that. If you have to go to cloud and you have do a couple of other things, then it might take longer. So I would say 6 months for productionization.
Okay, great. There's no question? Yeah.
So when you, so I just want to understand correctly, so if you create a product for Barclays, is it?
Yeah.
Are you then working as a division inside Barclays, so you get people in to create the model for you outside of your interface? Or?
No, we have created an internal team, and we have developed everything internally. The reason for that, we have this accelerator program called Barclays Rise, where we bring startups from different, and we incubate them and help them to solve business problems for them. And that's where we have seen they fail to actually give real value to the organization, because they come up with those exciting ideas, but they cannot integrate properly. They do not have created enough layers for themselves so that they can create like security layers, like integration layers for themselves. It's not about us, because if they cannot help us consume their service, we cannot help them to much. So, and the challenges we found in different ways, from bringing external vendors and even with like some of the big vendors, that those solutions are not customized according to your need. So if you're going for, I would clearly say like Microsoft, IBM, Google, they're not customized to your solution. If you're working on image classification, they have done a good work, they have done a good job on building the model, but it's not customized and personalized to your solution that can work. They have done amazing work on the voice to text, but they haven't done it for African accents or the local accents. And you still need to train those models. So the amount of work that you will have to train those models further for your personalization will be big. So you don't want to do that. So instead of doing that, you would rather prefer doing things in-house. So this is something which is capability for your organization, future capability, because you are investing in your technology, you are investing in the future, and that was the learning for our organization. So we started building the team, training them, giving them all kind of assets and whatever was required, and that's where it took quite a bit of time also to get that agreement from senior management, but it's kind of working. So we have been able to prove a lot of value internally. In last 1 year, I would say we have delivered 20 POCs with a team member of 12 and almost 3 products in production. So I guess that's a good achievement. So it's not a big deal, but it's the right understanding that you need to have to start a team inside your organization.
So if I've got an issue with the episode, can I speak to you about?
Sorry?
If I've got an issue with the episode banking app, can I speak to you about?
Not sure, because it's a big organization and everyone is boxed. So
you also have apps?
Yes.
Oh, there is, thanks. Yeah.